Hey there, folks. This is going to be your notes on 2.7% of change, and I'm writing with a highlighter, which I've told you to never do. I stand by that. This was an accident. All right. I will correct that error. So today we are learning about percent of change. This is a little different from your normal percentages that you are familiar with, typically dealing with in the past, because when we are talking about percents for like your grades, we are taking some amount, so we're saying the part, and we are going to be looking at it over the whole, okay? When we are looking at percent of change, we are going to be looking at the change over the whole. So not this. We're looking at change over the whole, and what that's going to look like is the original minus the final, or the final minus the original. So we're going to look at, let's do final minus original. Over the whole. What we're going to be able to do to figure out what percent this is we can actually set it up and make it a proportion. You are hopefully familiar with using the percent proportion, but basically if you have a percent proportion, you're going to put your part over whole or your final minus original over whole, and then you're going to put it over the basically percent number over 100, and that is going to give you your percent. So let's do an example. Let's say that I have an original amount of something of 20, and then after the change I have 23 of this thing. So let's say it's stickers, whatever. What I need to do is I need to say, all right, well, the final minus the original over the whole is going to be equal to the percent over 100. So this is finding percent of change. All right, so if I'm plugging this in, I'm going to say final is 23 minus 20 over over 20, because we use the original amount. So actually, we need to go and replace whole with original. I'll try to add that in everywhere else. You're going to take the original because that was your original whole. And that's going to be equal to your percent over 100. We can actually put the percentage as like a variable. So let's say it's X, and we're trying to find that percent of change, X. All right, now I need to simplify this before I can do anything else. I'm going to say 23 minus 20, that is 3. So 3 over 20 is X over 100. And this makes sense, right? Because when I'm looking at this, the difference, the change, was a change of 3. There's a difference of 3. That's how much this thing changed. What we want to figure out is what percentage that would be, because it provides some perspective into how big of a difference something has actually undergone, basically. So as you can see, I have started cross multiplying here. I'm going to go through the rest of the steps and get 20x equals 3 times 100, which is, so 3 times 100, which is 300 right there. And then this is a one-step equation. So I solve it like a one-step equation. I'm going to even just cover everything up. That's just a one-step equation. Don't think about it as anything else. You don't have to worry about it. I divide by 20 on both sides to solve for x. And then I have 300 divided by 20, which is 15. So what this is telling me is that it was a 15% change. So it changed 15%, but when we are looking at this, especially, well, just in general, in real life, especially, you want to know what type of change that was. Was it a change where it increased or a change where it decreased? So we're going to look at, is our percent change a percent increase or a percent decrease? So here we had an original of 20 and a final of 23, so we went up 3. So that means that we have a 15% increase. And that's going to be your answer. That's the percent change that happened. Now I want to show you what happens if you have percent decrease, because if you follow this equation and plug things in every time, you are going to have something that helps you figure out if it's percent increase or decrease. And you won't have to look back at your original numbers and think about it as much, okay? So let's look at another example. So if we have an original of 25 and then our final is 17. Okay, I'm going to do this the exact same way. My final is 17, so I put in 17 minus 25 over my original, which is 25. And that's going to equal x over 100. So I'm figuring out that percent. It's going to be the same deal. Before I can cross multiply, I need to simplify that top up there. I'm going to get negative 8 over 25 equals x over 100. And that negative is important. That's going to actually be the difference between a percent increase and a percent decrease problem. So we're going to just continue on with it and worry about what really happens with the negative when we get done with the problem. Okay, so we're going to cross multiply. Ooh, that was messy. All right, and I get negative 8 times 100 equals 25 times x. So negative 800 equals 25x. Divide by 25 to solve my one-step equation, and I end up with negative 32 equals r. Oh, geez, sorry, x. Okay, so what does this mean? This means we have a 32% change. And you know that this is actually a percent decrease problem. The way that you will be able to tell if you use that model every time is if you have a negative number, if the percent is negative, then it's a decrease. But you have to make sure that you put the final first, otherwise it's not going to work. So then, on the other hand, if your percent is positive, then you know that it's a percent increase. Okay? So I'm going to give you a try problem. We're going to do it right here. So if you have an original of 66, and then they actually change the words on me because they're being obnoxious. Here's like the final. They also call it new, the new amount of 30. Find the percent change using that equation, okay? Pause your video. And you should get approximately a 55% decrease. So you ended up with like a negative 55 approximately, and that's what gives you a 55% decrease. Okay. So tomorrow you're also going to be working on some word problems that involve percent increase and decrease. I'm going to turn the page. I just want to do one of those pretty quickly. So like I always say, math ups the ante here and wants it to be a little more complicated. So there is a possibility that maybe we know the percentage that we increase. Like maybe we know that we had a 10% increase. This is in passengers over a period of time. But let's look at this type of problem. A percent increase. If we have, for our new amount, new, or we can say final, we have 17.22. What was our original? We are going to be able to use that same formula, but we don't know this. So what's that going to look like? We would say 17.22 minus, okay, now my original, I'm going to be calling my x, okay, because I don't know my original, minus x over x equals, now normally I would put my percent or my variable, but I know my percent is 10, so I do 10 over 100, and that is what goes on that side. So this is actually a pretty involved proportion for you guys to solve. So I actually can't simplify anymore. I just need to go right into the cross multiplying part, okay? So I'm going to just do that. And remember, it doesn't matter how goofy it looks on the numerator or the denominator. When you're cross multiplying, you just go for it, okay? So you're going to put whatever the larger piece is, 'cause this has multiple terms in it. You're going to put that in parentheses, and then whatever it's being multiplied by equals, and then we'd have 10x. So this is going to be needing distributive property. So, boop, boop. So I would end up with 1,722 minus 100x equals 10x. Okay, now, once again, when we get to this step, we just have an equation. Normally we have normally we have one-step equations where we just have to do one thing when we've been dealing with proportions before. But this time we have a two-step equation, okay? So I need to move all of the x's so they're on the same side of the equal sign. Ooh. Just look at that. So this is the x, this is what's attached to the x, it's the 100. So it's a minus 100. I need to add 100 to both sides. Might help to have my line there. that cancels out like that, and I get 1,722 equals 110x. Now, this is what we're used to looking at when we have proportions. It's a one-step equation, so I just divide by 110, and I end up with 15.65 equals my x value. So that was the original. You can do that with knowing the original and not the final as well. That's going to look more like, we'll say our final is x minus, our original is 2 over the original, and then we're saying that it's a 50% increase, okay? Something like that. When you cross multiply, it's going to be the same kind of process. You're just going to get x minus 2 times 100 equals 2 times 50. So this just gets a little bit easier for you because you won't have the variable on both sides like you had here. So you'll be moving things around for the two-step equation a little differently, but you're still going to be doing distributive property and solving the equation, okay? Hopefully this helps you. Remember to look at IXL, look at their explanations. When you're working on that tomorrow, make sure you show your work, and I'll see you later. Let me know if you have any questions. Thanks. Bye.